Okay, so now this is the second example for to lecture 8 here, openMP example. Now we want to do the pi calculation with openMP, and this is actually pretty simple because all we need to do is to use the appropriate pragma. So hopefully this won't take that long. So what I have done here is I made another copy of the lecture or of the serial version, and I renamed it as openMP. Yeah, so we can here again run this. Now we need different arguments instead of p threads. We have to compile this with f openMP, and the name is main openMP. So OMP. Okay, so there's no openMP in it yet, but it should still compile even if there's no openMP in it yet. And then we should also expect that it runs. And now this is the usual serial code, so we expect that it takes roughly 4 seconds, four and a half seconds, roughly. Yeah. So now we are in the same code as before. So if you watch this online, you may want to see the previous video. Now what are we going to do? So now this is the place where, again, let us remind, we are now having this prepared for actually using MPI, yeah, where we had, again, my rank equal to 0. And then we were using my rank, so basically this thing here. In order to loop this up. So if we want now to split this into a loop where we use now my rank or something similar, say we'll have, okay, we'll split this up into again, I don't know, should I do 20? Okay, I put this into some divisions, say 100, yeah? So, because what number of, maybe I should not call this number of processes, I should potentially call this number of divisions, as long as I don't have number of intervals. I don't have number of divisions. Okay, so then I can put this. I replace number of processes into number of divisions. Oh, I have to replace them all. No results. Number of divisions. Okay, so number of divisions, I put there 100 now. Yeah. So in here, I would now go through a loop for, say, now be old-fashioned and call this thing I. I equal to 1, I smaller than number of divisions, check, I plus plus. Yeah, so only because I don't have a lot of time left for today. Yeah, so I'll open the scope, and this would go on to actually add up here in the result. I hope I'm making this correct. So then we see we're also testing how good our MPI, our openMP is doing, because now we want all of them to write to the same result. Yeah, but this loop should simply add up here. Konstantin, is this going to work? It's going to work, right? Why is there? Because here's a comma. That's you know, I'm using Mathematica a lot, so I write for loops. I always write for loops with comma instead of semicolon. Yes, so this has previously been gone over my rank. Now it has to go over I. So this is the normal loop. Now we put it into a loop. Let me save this. And okay, there's no openMP in it so far. Yeah, we just made a loop. Let's see whether it still works when we use the loop. It still works well. Okay, it works, but it gives us a shitty result. Why does it give us? Why is the result so bad? Did I miss number of divisions? Ah, okay. I should start the loop with 0, not with 1. Okay, let's try this again. Ah, much better. Yeah. So, okay. Always test your code. Always test your code. So, now we got this 4.7 seconds again. Now what we would like to do is to make this for loop here parallel. And for this we are using, so now we have to call openMP. And all we need to do for this is to use the pragma. OMP parallel for. Now we default to shared, so everything that we define in here will, no, not everything in here will be shared. Global A. Default, okay. Okay, we are not sharing everything here. We have some private stuff. So private, what would we put private? So because we are in a loop, apparently this doesn't matter because it worked anyway, this const double. Why can I have const double in a loop? This is also amazing. So these things here these things here, they should be the local A and the local B, they should be private to myself. So I call this local A, local B, and also our local integral, integral, this should also be private, my opinion. So let's save this, and that has not been declared. Okay, so apparently this is, let me briefly go outside here. Okay, so I see. So maybe I've said something wrong. So the internal variables, they would always be private to the loop. Is this correct? Because the example that we had here was x and y were defined outside. Yeah. Okay. So always good to check the professor, and that professor has to check himself. Yeah. Here we can, so the local integral is something that's defined outside, yeah? So we have to declare that this is private to the loop, but what is defined inside the scope of the loop would automatically be private. Yeah? This is why it tells us that they have not yet been defined here. Okay, then remove this again, save this, and try to compile it again. Now it compiles, and now it runs. It has taken, so previously it has taken like 4.7 seconds, now it took 1.3 seconds. Again, this may be related to the number of well, this how is this called, the environment variable, openMP num threads, which we have now set to 4. So I will set this to a higher value, export openMP num threads, and I will set this to, I don't know, I put it to 16, so there are 20 cores in one computer, in this computer, and I run it again, and now, yes, now it takes 0.4 seconds. So, because I use more parallel threads. Okay, so basically that's it for today. Thank you for coming, and see you in 2 weeks now.